Here's problem number 2 from assignment number 6. We're given a function, we're asked where is it increasing and decreasing. So let's go ahead and take the derivative and find out what f prime of x is equal to. It is 5/3 x to the 2/3 power minus 5 times 2/3 times x to the negative 1/3 power. When does that equal to 0? I would be tempted to factor out the smallest factor of x possible, which is x to the negative 1/3, and when I do that I get 5/3 x minus 10/3, or in other words I get 5/3 x minus 10/3 on top and x to the 1/3 on bottom. And now I can see that there's going to be critical values at x equals 0, because that would make the denominator 0. Also, where the numerator is equal to 0, which is 5/3 x minus 10/3 equals 0, which is 5/3 x is equal to 10/3, and then when we multiply both sides by 3/5, we get 2. So we get critical values at x equals 0 and x equals 2. So we've got a critical value at 0, a critical value at 2, and f prime when x is greater than 2, it's all positive. When x is less than 2, it's negative. And when both of them are negative, it looks like we get a positive value. So the intervals of increasing are going to be from negative infinity to 0, but not including 0, and then from 2 to infinity, we include 2 but not infinity, and intervals of decreasing from 0 to 2. Again, actually, you know what? It would include 0 on both of those cases. The function is defined while the derivative is not defined there. What are the local maximums and minimums? Well, f of 0, which is equal to 0, is going to be a local minimum because f prime is 0 is undefined, and f prime goes from positive to negative at x equals 0. F of 2, which is going to be 2 to the 5/3 minus 5 times 2 to the 2/3, whatever that is, will be a local max, again because f prime of 2 equals 0 and f prime goes from negative to positive at x equals 2.